Good evening, everyone. Myself Gautam Sharma. I welcome you all in Sapiens Education. For more details, you can contact our website www.sapienseducation.com. Today, I am going to teach a laws of motion and Newton's second laws as well as momentum. Okay, a part. This is your part two video, and for part two, that is Newton's first law, inertia. You may go for in a part one video. Okay, now I'm going to discuss about this two topic. Okay, now before discussing two topic, I want to make you clear that what is the weight. Weight, you know that weight of a body is the force with which earth attracts. For example, this is a body. Okay, this is a body, and weight will act in a downward direction like mg. Why weight W equal to mg? It is actually the force. Okay, force, you know, m equal to m into a, but in place of acceleration you need to write g. Why? Because g is also an acceleration due to gravity of the earth. So whatever there will be object there, it must be have some weight, and that weight is equal to mg, and which act in a downward direction. Okay, another is your reaction or a normal reaction force. So let us see reaction force. Let us consider a table like this. Okay, an object is placed in this table, right? So an object is placed in this table, and you know that weight is acting downward, that is mg. This is your weight. Then this table will also apply a force which is in just upward direction and in equal magnitude, and this is called reaction force. R is your reaction force. R is your reaction force, right? And this reaction force will be equal to mg. Understood? Similarly, if body is kept in any slant side, and if it has an angle like theta, and object body is like this. Okay, and if weight is acting here downward, that is mg. So what will be the reaction force? So reaction force will always act on the surface, and it will always be perpendicular, that is 90-degree. So if here it is your surface, so there must be a 90-degree reaction force like this. Okay, so if I will split this, the component of mg, though, so mg will be mg cos theta here, and one component is your mg sin theta. Mg sin theta, as we all know in a vector to split any of the vector. Now reaction force will be always perpendicular, always in a perpendicular direction, that is r. Okay, and as we know that r is equal to mg cos theta. Okay, so this is what I want to discuss. I hope you all have understood. Now I will use it in a numerical more details. Now there is tension force. What is actually the tension force is? The force exerted by the end of the taut string, rope or a chain against pulling applied force is called tension force. The direction of tensile is always from the body. See here, this is your body. In red color I am showing you. This is your body, and we are applying a force to move this body. So tension will be equal to that force. How much you apply a force, you will get which is equal to tension. Tension is the force applied by you, and it will always move from away from the body. See here, if you are applying a force away from body, so tension will act away from the body. Tension won't act like this. Understood? Now I will talk about spring force. Every spring resists any change in its length, and this resistive force increases with change in length and is given by F equal to minus kx. Here x is the change in a length and k is the spring constant. Okay, now I will explain you more details here. Okay, let us consider let us consider a normal bench is here, okay, and you have connected one spring and it is normal, okay, and it is connected with this object. Now it is a normally kept, okay. Now if you want to apply a force like this F, so what will happen? So spring will get stretched, and spring structure may be like this, yes or no? Maybe like this. So after applying a force, so spring's displacement will be like this, okay. So what will be the net displacement? It will be the x, okay. Now the more you apply force, the more spring will apply in a backward direction, okay, and this force is directly proportional to displacement. Why displacement? If you will increase the displacement, then what will happen? If you will increase more and more displacement, if it will be more, distance will be more, you need more and more apply, okay. If you will stretch for 1 centimeter only, it will required only few Newton force. But if you will increase the distance, then force will directly proportional to x, okay. And if you want to remove this, so this will be minus k into x, where k is your proportional spring constant. K is your spring constant, okay. And why negative sign? Negative sign indicates force always act in opposite direction of the applied force. Spring force acts opposite to the direction of applied force, okay. Let us see here. If you are applying applied force, so spring force will be F equal to minus kx in just opposite direction. If it may be the case when you compress the spring, if you will compress the spring, then spring will just apply a force F equal to minus kx, and that will be this direction. If you are applying a force in left direction, so spring force will apply in right direction. Spring force will apply in a right direction. I hope you all have understood this. Now I will talk about linear momentum. What is linear momentum? The total quantity of a motion possessed by a body is known as the momentum. Total quantity of the motion. When we are talking about linear momentum, for example, body is kept here, so there is no momentum. But if body has some velocity v, then it gets some momentum, okay. And we can say that body has some momentum when it is in a motion, and it is measured by the product of mass of the body and its velocity. For example, it has mass m, so momentum will be what? Momentum will be equal to mass into velocity, and since velocity is in vector, momentum is also a vector quantity. Understood? Now I will give you some example and you need to find momentum which has more momentum. Before that, I will just specify some unit of the momentum. What is unit? Unit will be definitely mass has kg and velocity has meter per second, so momentum has unit kg meter per second. And dimension you can easily find, mass is m, lt minus 1 is your velocity is dimensional unit. So this is your dimensional unit, okay. Now let us consider two bodies. See here, one body has mass 5 kg, velocity 10 meter per second, and another body has mass 5 kg but velocity 20 meter per second. So it has how much momentum? 10 into 5, so this will be 50 kg meter per second. And how much this velocity momentum this object, for example this a, this is a b object, so what will be the momentum of b? Momentum of b will be 20 into 5, so this will be 100 kg meter per second. See, in spite of being same mass, it has more momentum. Why? Because it has more velocity. Now in case of second case, you will see in second case, suppose one body has a mass 5 kg and velocity is 10 meter per second, and another body has also same velocity 10 meter per second, but the mass is your 10 kg. Now if body, this is your b body or this is your c body, so momentum of b will be how much? So this will be 50 kg meter per second, and the momentum of body c will be 10 into 10, that is equal to 100 kg meter per second. What does this means? If mass is more with a spite of same velocity, then the more mass means more momentum is there. So momentum, not only momentum indicates momentum is more when its velocity is more, it also depends upon the mass. Understood? So more mass, more momentum may happen. So finally we get to come to the conclusion that momentum is not a single quantity, physical quantity. It depends upon mass, it depends upon velocity. Okay, so mass into velocity, it will be a momentum. I hope you all guys have understood this momentum, right? Now I will talk about Newton's second law of motion. Okay, it is the rate of change of linear momentum of a body directly proportional to the external force applied. Again, listen to me. Listen, the statement is very important. The rate of change of linear momentum of a body directly proportional to the external force applied on it. And this change in a momentum take place in the direction of the force applied. Okay. Now I will show you some example. See here. See what happened here. He has applied a slow. See two figure. Try to see and feel it. Okay. See here, he applied a slow force, so this body has less acceleration. But he applies a large force, the body becomes more accelerated. Means body has more momentum. Understood? So when I will talk about diagram, diagrammatically also I will make my own diagram how to create a momentum and change in momentum. Let us consider a body, okay, of a mass m1 or m, okay, and it has an initial velocity u. It has initial velocity u, and when applies a external force, then what will happen? This body will come here, and its velocity, final velocity will be v, and mass will be m. So let us consider a body of mass m, okay, initial velocity is u, final velocity is v, and the time taken to travel this distance, let us or time for which force is applied, F is your force applied, and T is your time for which force is applied, okay, force is applied. Understood now? Now tell me, if I will apply more force, then more velocity will change. For example, now velocity is 5 meter per second and its final velocity is 10 meter per second. If I will increase force by 2 times, 3 times, 4 times, so definitely it's for the same time velocity may be 20 meter per second or velocity may be 40 meter per second. It means that more force you apply, more rate of change of speed happens. Understood or not? Now let us consider initial momentum is how much? Initial momentum is how much? Mu. Final momentum is how much? Final momentum is how much? Mv. If I will talk about rate of change of momentum, then how you will write? Rate of change of momentum, how you will write? Rate of change of momentum, and this will be written as Pf minus Pi divided by T. Now, Newton's, if you will go to the Newton's second law, you see the statement. What they are telling? As per the Newton's second law, the rate of change of linear momentum of a body is directly proportional to the external force applied on it, and this change in momentum take place with the direction of force applied. Okay, so can we write here? Force is force is force is proportional to rate of change of momentum as per the Newton's statement. Rate of change of momentum. So F, can we write here F equal to K, and what is the value of rate of change of momentum? Pf minus Pi divided by T. So this is what K mv minus mu divided by T. So basically K mass V minus U by T, and as we know that V minus U by T is what? V equal to U plus AT. By using this you can find V minus U by T as acceleration. So finally F equal to kma. Now by experimentally they have taken K is equal to 1, so we got F equal to ma, and this is the mathematical model of the second law, Newton's second law. So this is the mathematical model of Newton's second law, F equal to ma. So you can see here how I have derived this. Okay. So you need to explain it. So Newton's second law gives the quantitative definition of the force, that is F equal to m into a, and this is a vector quantity. So this is what Newton's second law states, and I hope you have understood the derivation part, and I hope you will able to apply this derivation in solving a numerical, right? Now you can understood, see here F equal to ma. Little force, less force means less rate of change of momentum. More force means more rate of change of momentum. See, in second case its velocity increase very high. It means that more force you have applied, more acceleration you are getting. Understood? So I hope you have understood Newton's second law. Now I will talk about the application. Okay, what is the applications of Newton's second law? See, basically what happened, in Newton's second law, when a player is playing and when he catches the ball, then he just make a hand back. Why? Backward movement of hand is to decrease the force, means to say decrease the force. Okay, why we decrease the force? Because if it will be very high force, then it will get hurts. So to decrease the force, what we have to do? See, force has a formula, what? M v minus u by t. What actually you are doing? Changing the momentum of a ball. Initially some momentum of the ball is there, but when you take a catch, you directly changes the momentum. Okay, now how rate of change of momentum and force is, as you know, that directly proportional. If I will decrease the rate of change of momentum, then definitely force will decrease. So for that you need to increase the time. So when a player makes a hand down, so he is just increasing the time, and if he is increasing the time, if F equal to m, you know that v minus u by t, if he increase the time just by making a hand hand backward, then it means that force is decreasing, and if force is decreasing, you may get less hurt or player may get less hurt. Second case, if you will jump on the sand and there is a concrete one, so definitely you will prefer sand or water to jump from the highest floor or a floor above, or some at some distance. If you want to jump, you will definitely prefer this case. You don't prefer this case. Why? Because when you jump from this, what happens? So the change in a shape happens, and when this change in a shape happens, it takes a time. It means that you actually increase the time, and when you increase the time, rate of change of momentum decrease, and when this decrease, it means that force is also decreasing. As you know that your mass will be remain constant, mass will remain constant, so that's why we prefer to jump on the sand or water. So these are the two applications. So there are several application in your life. You will come to know. You try to read that. Okay, I hope you have understood second law of motion. Okay, so this is the definition of second law of motion. Now I will discuss about some important points of a second law of motion, and this is what written here, also written. In second laws of motion, force equal to 0 means acceleration is equal to 0. Definitely. If net force is 0, so acceleration will be 0. Second law, obviously consistent with the first law. Second law of motion is vector law and is equivalent to 3 equation. It is a vector law and it is equivalent to 3 equation. If you are taking change in momentum in y direction, so you have to write here everywhere y. If you are taking in z direction, you have to write in terms of z, and if you are taking in a x direction, so you have to write in a x form. Okay. Second law of motion is a local relation, which means that the force at a point in a space or location of a particle of a certain instant at a time is related to a, and that point at that instant. Acceleration is how now is determined by the force, and now not by any history of the motion. Whatever the object is, it is in a rest, if it is in a motion, if it is in whatever there is, if you are applying a external force, so it will get accelerated. If you are not applying external force, if you are not applying external force, then it will be, what will happen? No. What will happen if you are not applying external force? So no acceleration is there. That is the thing you need to remember in Newton's second law. I hope you all have enjoyed this session. Thank you for watching my videos, and for any query, please comment below in the comment section. Okay, I will take and I will try to clarify the doubts. Thank you everyone.